something for you to think about. You can write an evaluator for any language in any other language. Okay? They're all completely equivalent in power in the sense of what can we compute with them. They're not equally equivalent in expressive power, which is how easy is it to say what you mean. But they're all equivalent in terms of what we can compute. So if I were to say, I want my class, my introductory freshman computer programming class, to write an interpreter, and I want it to be easy, you might imagine that the thing to do would be to give you a very powerful implementation language, like, say, Ada, which is a language that has everything under the sun in it, or maybe Java, which is semi-everything in it, as the language that you write the interpreter in, and some really trivial language, like, say, BASIC, language they used to use on 8-bit microcomputers, as the language that we're implementing. So maybe writing a BASIC interpreter in Java would be the easiest possible interpreter assignment. Turns out not to be true. Turns out the easiest interpreter in the world is a scheme interpreter written in Scheme. And that seems paradoxical, because I'm saying on the one hand, Scheme is the simplest language that there is, and on the other hand, Scheme is the most powerful language that there is to write an interpreter in. And how can it be both the simplest and the most powerful? That's one of the hardest ideas for you to take away. And the reason for you to take it away is not so that you become Scheme fanatics. That's not my goal at all. I'm a Scheme fanatic, but you don't have to be. I would like you to be a simplicity fanatic. Okay? I would like you to understand that just as in mechanical engineering or civil engineering or anything else, the best solution is the simplest solution, not the most complicated one with a lot of bells and whistles. And that turns out to be true in programming languages also. So if you ever find yourself designing anything like a programming language, and most of you are probably not going to be designing general purpose programming languages, but you might well be designing special purpose programming languages, like the language that the user of some game uses to say how to move next. That language might be defined in terms of gestures with a joystick or something, rather than stuff that you type. But it's a language. It's a special purpose programming language. And if you find yourself designing one, make it simple. And the way to make it both simple and powerful is to have powerful ideas in it, like, for example, but not only, Lambda. Okay? So Scheme is a simple language because it has a very uniform syntax. So all those parentheses that everybody complains about when they're first introduced to Lisp, they have an important purpose, which is you don't have to understand anything about the meaning of a program to understand how to divide it up into chunks. The dividing up has been done for you by the parentheses. And the other piece of the another piece of the simplicity is that that notation with all the parentheses is both the notation for programs and the notation for data. That's how we represent lists. Okay? If we had a notation in which programs were full of parentheses and quoted lists were full of square brackets instead, that would make our job harder, because we wouldn't be able to take a computer program and view it as data easily. But as it is, after read has done its work, the program that we see actually isn't full of parentheses. It's full of box and pointer diagram, because that's what read gave us. Read is the thing that translates the characters you type, those parentheses and things, into box and pointer form. And then eval is the thing that takes that structure of boxes and pointers and assigns a meaning to it. And then thirdly, it turns out that having a language in which procedures are first class makes writing an interpreter really easy, especially as we get into the more advanced variant versions of the evaluator. You'll see that. Okay.